Today we're going to start talking about three-dimensional figures. So everything we did in chapter 8 was flat shapes, square, circle, trapezoid, two-dimensional shapes. Now we're using polyhedron for three-dimensional shapes. Poly, of course, meaning many. And so polyhedrons, just like polygons, have many sides, but they don't have any curved edges. So our cone, our cylinder, our sphere, those are kind of their own things. They're still three-dimensional shapes. We're still going to study them, but they're not polyhedrons. A polyhedron would either be a prism, which if you look at a prism, you might remember that a prism has a top and a bottom. So a prism has what we call two bases versus a pyramid, which just has how many bases? You're right, it only has one base. And then a pyramid comes to a point. So you've studied these shapes in elementary school, in middle school, and you might remember that they're named by the shape of their base. So a rectangular prism has rectangular bases in the top and bottom. Versus here, a triangular pyramid has a triangle base at the bottom. So the base is like how you name it. The base is how you name it. So if I look at this one, the first one I would say, is it a pyramid or is it a prism? You're right, it comes to a point, so it's a pyramid. And then for what kind of pyramid, I would look at the shape of the base. 1, 2, 3, 4, 5, 6. What's the name of a flat shape with 6 sides? You're right, it's hexagon. So we call this a hexagonal pyramid. What about this one? Is that a pyramid or is that a prism? Well, it has two bases, so that means it's going to be a prism. And I think the shape of those bases are rectangles. So that is a rectangular prism. This one here, well, let's do the shape of the base first. Looks like a square or a rectangle. Sometimes it's hard to tell the difference. I'm going to say that that's a square. And then that comes to a point, so it's a square pyramid. We have a star by number 4 because we're going to use this shape a lot. And a lot of people think the base of this shape is a rectangle. But it's not. The base of this shape is actually the triangles. It's a triangular prism. It has two bases. The two triangles are the bases. The triangular prism. So now we're going to turn our focus just to the prisms, and we're going to talk about the faces and then the edges and then the corners or the vertices. The faces are the plane surfaces, the flat sides of the shape. The edges join the vertices, join the corners, and then the vertices are like the actual corners, right? So here, the N, a lot of people ask, like, what is the N? N is the number of sides in the base. The number of sides in the base. So the base is the bottom and the top here because it's a prism. So the base here has 4 sides. 1, 2, 3, 4. The shape of that base looks like a square. So the type of prism is a square prism, aka a cube. You could also call that a cube. The number of faces are basically the flat squares that make up this cube. So if you think about a dice, 1, 2, 3, 4, 5, 6. Isn't there 6 sides to a dice? The vertices are the corners, and I just like to do those with dots. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corners. And then the edges connect those corners. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 faces, 12 edges, and 8 corners. Let's go on to the next one here. This is another prism. And the shape of the base here is a triangle. So it's got 3 sides in the base. This is a triangle base, so it's a triangular prism. The number of faces, well, I have 2 bases, and then I've got 3 faces around the side, so that's 5 altogether. The corners, 1, 2, 3, 4, 5, 6 corners. And the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Now eventually we're going to see a pattern here, but for right now we're just filling them in. Here, this is one of those, again, where the bases don't look like they're the bases, but they are. The bases are those hexagons, making that a hexagonal prism. Do you know how many faces there are? There's a lot. 1, 2, 3, 4, 5, 6, kind of going around, plus the 2 bases makes 8. Corners, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then for the edges, I've got 6 edges here, another 6 edges here, and then 6 edges that connect them is 18. Now, as you get more, sides in the base, it gets harder and harder to count. So we're going to look for these patterns. So the first pattern is asking number of faces. So if the n was 4, faces was 6. N was 3, faces was 5. N was 6, faces was 8. Do you agree that the number of faces is always 2 more than the number of bases? How about the corners? 4, 8, 3, 6, 6, 12. You're right, you double. And then to go to the edges, 6, 18, 3, 9, 4, 12, we're going to triple, or 3 times n, or 3n. So you might have a question in the homework like, what if it had 100 faces and sides in the base? What if n was 100? I'm just going to squeeze that in. If n was 100, then the faces would be like 102, and the vertices would be 200, and the edges would be 300. You would just plug those values in. The last part is about visualizing like a folded up version. So I have to picture, you've seen something like this before when you would fold it up, right? And I know it's hard to draw, but you'd want to try and draw that folded up cube. Do you know what this one would be folded up? You're right, it's a cylinder. It's good for our brains to fold these back up. And the last one, do you know what this one would be folded up? The square would be at the bottom, and then the triangles would kind of come to the top. So this one folded up would be a square pyramid. So an introduction to 3D shapes, specifically talking about prisms and the number of faces, the number of edges, and the number of vertices.